Today's topic is going to be momentum. Momentum is the product of mass times velocity. So momentum is essentially inertia in motion. Remember we talked about inertia in the last lecture, and we said inertia was the tendency of an object to remain in its state of motion. Objects at rest stay at rest. Objects in motion stay in motion until acted upon by an outside force. Well, objects in motion have what we call a momentum. Momentum symbol is a P for some reason, and it's mass times velocity. Our long jumper here has a lot of momentum as he takes off. He takes his mass, he takes his velocity, that gives him that momentum. If we look at our scenario of the two trucks, the white box truck would have more momentum than the red truck if they have the same velocity. The only way for them to have equal momentum is for the red truck to be going faster, to have a bigger velocity. The relationship between mass and velocity are inversely proportional. If the velocity goes up, the mass will go down for a given momentum. So if they have equal momentum, the red truck would have to go faster than the white truck. If you want to change your momentum, you have to apply a force over a period of time. If you think about your car, you're driving down the road in your car and you come try to brake to stop your car, to change its momentum. Well, the brakes apply a force. The car continues to move forward for a period of time until it stops. So there's a force and a time required to change your momentum. This is known as impulse. Impulse is what is required to change your momentum. For your impulse, the force and the time are related. They're inversely related. When the force goes up, it's because it's a small time. To decrease the force, you increase the time. Here are three examples where increasing the amount of time is going to increase the impulse. Now, if you look at airbags, what do airbags do? Airbags are there to help you when you are in an accident. So when you're in an accident and you don't have an airbag, you don't have your seatbelt on, your car stops very quickly. So to change its momentum, it has a very small amount of time. This means that you're going to have a very large amount of force acting on you. The smaller the time, the bigger the force. So what an airbag does is it increases the amount of time it takes your body to stop. As the time goes up, the force goes down. That's an inverse proportion. So airbags, what they do, increase the time, decrease the force. Same thing with parkour, right? When you're jumping off this ledge onto the ground, what he does is he rolls. By rolling, he increases the amount of time it takes him to stop. If he were to just stop very stiffly, or if he were to jump off that ledge and run into a brick wall right away, stop immediately, there would be a large force on his body and that would hurt. But by rolling, he increases the amount of time it takes him to stop, decreases the force on the body. In the follow-through is very important for sports. If you ever played sports as a kid or whenever, your coach always said, follow through. When you're hitting the baseball, when you're hitting the golf ball, when you're playing tennis, any sport, follow through. It's essential. What the follow-through does is remember, your change in momentum is equal to your force times your time. The follow-through increases the amount of time that the ball and the golf club in this case are in contact. You're applying a given force. You can only swing so hard. That's your force F. By following through, you increase the T. So for F, you increase the T. That means you increase the momentum, which means it goes off faster. So a follow through allows the object to be in contact with the club or the racket or whatever, the bat, for a longer period of time, which increases the change in momentum. The conservation of momentum tells us that the total momentum of the system does not change. The total momentum remains the same. So the momentum before is equal to the momentum after. Now there's three cases here with our astronauts. The first case, equal mass, they push on equal force. You can see they move opposite directions with about equal speed. The second case, here he's going to push away this object. The other guy is going to catch it. He moves away with a faster speed than the object and causes this man to move away. And in the third scenario, you can see when he has the object strapped to him, he has a bigger mass. So after they push off, their momentums have to be equal. Since his mass is bigger, his velocity is smaller. So once his mass is larger, when he pushes away, he's going to have a smaller velocity because they both are going to have the same momentum because momentum is conserved. The conservation of momentum also deals with collisions. There are two types of collisions, elastic and inelastic. An elastic collision is when objects bounce off of one another, like the billiard balls. Each one of them is going to move around. Momentum is still conserved. That's why when you're playing pool, you use a larger pool stick when you're breaking, a breaking pool, a breaking cue, and that's going to allow you to give more momentum to the cue ball, and that momentum then is going to be transferred into the other balls, all the balls' momentums, and each ball is going to have its own individual momentum, but it can't be greater than the original momentum of the cue ball. An inelastic collision is one where the objects stick together. And you can see here this poor boy is running down the field thinking he has a touchdown, and a larger boy comes out of nowhere and tackles him. This is creating an inelastic collision. So the bigger boy has a much larger momentum than the smaller boy because he is bigger. So when they stick together, you can see how his momentum is transferred into the smaller boy and makes him stop immediately. Whenever you get tackled, it's much more force to get stopped immediately than to get drugged to the ground. And this takes us back to the impulse idea. If you're getting drugged to the ground, it takes a long time to stop you, small force. If you're getting tackled immediately, it takes a very short time to stop you, much larger force.